Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 1 from Chapter 2, which is talking about the tangent ratio. So just as a quick recap, when we're trying to solve for a missing angle or a side in a right triangle, there are a number of different methods that we can use to solve. The first one that we can look at is when we need to use the Pythagorean theorem, and that's when we have three sides. So you're only working with the three sides of a triangle. And with Pythagorean theorem, that is a squared plus b squared is equal to c squared. Now one thing that's really important is that when we're working with this right triangle, it doesn't matter what a and b are, but one thing that really matters is what the c value is. So the c value here has to be your hypotenuse, which is this longest side of your right triangle. And an easy way to remember it is that your 90-degree angle is across from it, or it points to the hypotenuse. Other than that, A and B can be either the other two sides, but just remember that you have to be using the hypotenuse for your C value. So that's only when we're working with sides. So when we're working with just angles, so this is when we're working with three angles. So here we would know two, and we'd be missing one of them. Then what we know is that if we were to add up all three angles, say we had angle A plus angle B plus angle C, if you were to add all three of those up, you should get 180 degrees. And this property actually works for any type of triangle, whether or not it's right or non-right triangle. And then suppose we're working with two sides and an angle, that's when we're going to be using one of the three primary trigonometric ratios. And these ratios here are the big ideas of our lessons. So by the end of this chapter, you guys will know what all three of those trigonometric ratios are, and you'll know how to work with them to find sides and angles. So specifically in this lesson, we're actually going to look at how to use a tangent ratio to solve problems. And in order to use a tangent ratio, you must be working with an angle and the sides that are opposite to that angle and adjacent to that angle. So when we're looking at a right triangle here, and say we had an angle, maybe down here in the bottom, we'll call that angle theta. So we're talking about the side that is opposite to the angle. We can draw a little arrow going across, and that one there points to the opposite side. And we're also supposed to be working with the side that's adjacent to that angle, which is the angle that's right beside, or the side that's right beside the angle. So this here is your adjacent. And when we say it's right beside your angle, we're not talking about this side here, because as I mentioned earlier, this one that's across from this 90-degree angle has to be your hypotenuse. So you can kind of eliminate which sides are which. I would probably start first with your hypotenuse. This one here might be your easiest to label. Then you can do the opposite, and then the last one there is your adjacent. I find that most people struggle with labeling your adjacent side. So if you label everything else first, even if you're not given those values, it'll help you to correctly identify which sides are which ones. So getting back to the tangent ratio, we could say that the tangent, so we say tan of an angle, so tan of theta is equal to your opposite over your adjacent side. So this opposite is the length of your opposite divided by the length of your adjacent. So you must be working with an angle, the opposite side, and the adjacent. One of those three will be an unknown, and then you should have the other two values. So now we're going to look at an example from your notes, which is example number 3, which is going to be a quick recap of both the Pythagorean theorem and then learning our new skills and applying it using the tangent ratio. So a support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It is attached near the top of the pole. What angle, to the nearest degree, does the cable make with the ground? So just as a quick recap, for those of you who took my Workplace 10 course, there is a little trick to when we're reading word problems, because it kind of sounds like a lot of information is being thrown at you, but we can make this simpler by underlining key words, or I guess even just key bits of information. So looking at our first sentence there, we have a support cable is anchored to the ground 5 meters from the base. So this right here is really important. This 5 meters from the base is really important because it kind of gives us an idea of what's going on. So here we're talking about a telephone pole, And then we have a support cable that's anchored to the ground. So here's my beautiful telephone pole. Then we've got this support wire that connects from the top and goes all the way down to the bottom. And here is the ground. So here we know that the support cable is 5 meters from the base. So that means 5 meters from the bottom of the telephone pole. So that's this horizontal distance here. So we can label that as 5 meters. Then it says the cable itself is 19 meters long. So that's this diagonal length here. So 19 meters. And then we know it's attached to the top of the pole, which is how I've drawn it. So we want to know what angle to the nearest degree does the cable make with the ground. So we're talking about the cable making with the ground. Here's our ground. Here's our cable. So obviously we're going to be looking at this angle right in here. We can also say this here is a right triangle because the telephone pole in a perfect world should be standing straight up, which makes it perpendicular with the ground. So here we're working with an angle and 2 sides. So in our perfect world here, we should be able to use our tangent ratio because this right now is the only ratio that we know how to use. But first what we should do is we should always label the sides of our triangle just to make sure we're using the right ratio, or if we have to go back and find some other information. So as I said, our first side that we should label is our hypotenuse, which is across from this 90-degree angle. So this 19 meters is your hypotenuse. Then our angle here is across from that opposite side. So here we have our opposite, and then the last side here is your adjacent. So one thing that's really important is that in order to use the tangent ratio, we have to be working with your opposite side and your adjacent. So I'll just write our tangent ratio over here. So we should have tan of theta is equal to your opposite over your adjacent. So in this case here, we have our adjacent and the hypotenuse, which doesn't make sense. We can't use our tan ratio for that. So what we can do though is find some information, or find our opposite side using the Pythagorean theorem. So that will be step number 1. And then second step will be to use the tan ratio. So according to Pythagorean theorem, we have a squared plus b squared is equal to c squared, and this c value has to be your hypotenuse. So if it makes your brains happy, we can label this one here as c. So here can be a and b. So your opposite can stay as a. So we have a squared plus b squared will be 5 squared, and c squared will be our hypotenuse squared, so 19 squared. Plugging those values into our calculator, we have a squared plus 25 is equal to 361. Then we want to solve for a squared here, so I'm going to subtract 25 on each side. So then we're left with a squared is equal to 336. Then what we want is we want just a. We don't want a squared, so we need to get rid of this square. So to get rid of a square, we're going to do the opposite operation, meaning we're going to square root each side. If you plug that into your calculator, you'll find that a is equal to 18.33 meters. So I'll just go ahead and fill that in here for our opposite sides. We have 18.33 meters. Awesome. So now we found that missing bit of information, and now we can go ahead and use that tangent ratio. So here we have tan of theta is equal to, so it's the length of your opposite side, so 18.33, divided by your adjacent, which is 5. Then we want to do is we want to get this angle theta by itself, so we need to get rid of tan. And to get rid of tan, what we're going to do is we're going to move it to the other side and take it using the tan inverse. So it's theta is equal to tan inverse, which you write as tan, to the exponent of -1, and it goes for this whole fraction here. So we want to make sure we put this in brackets. So it's 18.33 divided by 5. And the reason why I don't do this division just yet is because I don't want to have any rounding errors. So I always try and leave everything in my calculator, or leave all my calculator work until the very end, whenever that's totally possible. So then to put this into your calculator, you're going to go second function tan, and then open bracket if your calculator doesn't, then 18.33 divided by 5, close your bracket and push equals. Then you should get a rounded value of 75 degrees. Then our last step here is that this one here was a word problem, so we need to finish this off with a sentence. So we could say the angle made with the ground and the wire is 75 degrees. So that is everything here for this video. So thank you guys so much for watching. And if you have any questions, make sure to come see me in class or text me on Remind 101.